Yes. So hello everyone. So good evening. So we are going to continue the NoSQL database. So the title of this course is the Hadoop and NoSQL database. So as I introduced regarding to the big data at the beginning of this semester, it is to the NoSQL database. Actually, coming from the big data, the platform, which is the Hadoop, then that is the Hadoop the database that will Hbase database that will be covered in soon. So meanwhile, so we are going to continue to see what is the big data solution, which is the Hadoop, and how we can use the big data to process such a data. So today I'm going to introduce last week we talked about the two main components of the big data system, which is the Hadoop Distributed File System, HDFS, and then we mostly discussed about the HDFS. Then we had the programming framework, the MapReduce. So today we are going to continue to talk about the MapReduce programming, and also I'd like to introduce based on the MapReduce as well as the HDFS, there are some softwares which are based on such a Hadoop system, which is called the Hadoop Ecosystem. So today I'd like to introduce such the Hadoop Ecosystem, the software. Okay, before we start, there was a due for the phase 1 of test 1, the project of NoSQL database last time, which is basically select your NoSQL database and very briefly the research on such a database. What is the name of that, and the URL, and the brief 1 or 2 paragraph of the description, as well as the type of model of the NoSQL database. So I already graded just before the class. So this is the list of the databases that I graded. So if you cannot see the name over here, which means one of the students select the Amazon Dynamo database, so which will be covered in the classroom. So I ask to submit again for the phase 1, select another the NoSQL database. Then if you can find your selected database as well as a link, it is fine. So, but sometimes it's a blank like this. I cannot figure out what is the type of such a database, whether multimodal or key value, and it's a document or graph and so on. So please give me the more details about such as the type or the missing information to me. And also some of the students missed the URL, so please give me the details of the selected database. Then we can see which students select which database and what they are doing for the NoSQL database project. As you can see, we have already the different types of the NoSQL database, so key value, document, and the graph already there. So we will discuss about such the different types of model near soon. And also you can see some of the database are popular, like the CouchDB are selected by the several students, and also Cosmos DB is the Azure, the cloud-based database. So those are the interesting topic that we can see what are the result of such a research on the NoSQL database here. Okay, so if you have any question regarding to the phase 1, please send the Canvas message, and I can reply. So if your database is not here, please I think right now Canvas is closed, so you can send the Canvas message to me. Okay. It's not shared. I thought it's a shared. But I thought it's a shared. So this is your selected database. So you can see the list of them. Let me go scroll down a bit, then you can check which database are selected for the TON project. So we have Cosmos DB, which is from the Azure the cloud system, and the Redis, which is popular, and the Firebase, and the Couchbase. So it's also very popular, the NoSQL database. And the React also KB, it's a key value database, and the LabelDB also popular, and the Sun. Okay. Yeah, I forgot to share this. Okay, so today we are going to cover the Hadoop Ecosystem as well as the MapReduce program. Also, after the class, there is an exercise lab based on the virtual machine. But as I announced the last time, that we are not going to have the exercise lab live. Instead, I'm going to share the link of recorded video. So after the class, you can complete the exercise lab by watching the recorded video. So Vamsi, the GA, contribute on the recording the exercise lab video. Okay. Regarding to the last exercise lab, some of the students had a problem to set up the virtual machine for using the VMware or the VMware player or the virtual box. So mostly when you have a problem on the Windows system, it is because of the hyper-threading. So in the BIOS program, you need to enable the hyper-threading that enable the virtualization. So that is the most popular reason why you cannot set up the virtual machine on Windows system. Mac OS. So if you are using Mac OS, so mostly it's okay if you are using the VirtualBox. So sometimes the VirtualBox doesn't work. At the time you can use the VM player, which I tested a long time before on MacBook, but last time the couple of students had a problem, but finally as far as I know so far, all students solved that problem. So please contact me or the GA if you have any problem on your VM, then we try to figure out what is the problem, then it can continue to work. Okay. Let me share the screen for today's. Okay, so what is the Hadoop ecosystem? So Hadoop ecosystem is the about the delay. And we share this one and this. Okay, so I think you can see the whiteboard here. For your reminder, I very briefly review what is the Hadoop the system. So Hadoop starts from the Google File System, so GFS. So Google actually struggled from the managing the bunch of HTML files. So they try to manage such a the big file. So finally they developed the Google File System. Then plus, so there's a programming interface which is called the MapReduce programming. So this is the today's topic. We will set aside this one for today's lecture. So Google File System has been released with the publication 2002, 2003. Then finally this is accepted as Apache Foundation the project. Then this time is named as the Hadoop. So we, the engineer of the Google File System, the Locality actually create a job, then contribute under such as the Apache Foundation Hadoop system. So Hadoop is the kind of general name of the such as the system. Specifically, the Hadoop has the Hadoop, the distributed the file system. It's a file system. So to deal with such as the big data, one of the way is to make the divide and conquer. So we can have a number of nodes, then store the data along a number of systems. At that time, we are going to use the file system because this file system is distributed along the number of nodes connected by the network. So this is called the distributed file system. Specifically, this is called the Hadoop distributed file system, in short, HDFS. So HDFS is one of the core components of the Hadoop, the big data solution. So when we are saying that do you know the big data system, Hadoop system, which means so whether or not you understand the HDFS, whether or not you have been using the HDFS, the distributed file system. Since so this is the file system, so it manages the file. What kind of file? The usually big file. So think about why we use such a big file. So mostly it's not the online transaction system. It's not like the banking transaction. It's not like the stock trading system. Instead, this one is mostly the batch job for analysis purpose, or when you have a bunch of files. So because of that reason, so to deal with such the big file, HDFS has several important features. So one of them is it has a 64 or 128 megabyte the block size. So which means when you read the data, you must load the block into the memory. Then finally, your computer CPU can understand, can read the data from the memory. So that is called the block. So block is the I/O unit. So mostly the normal file system, the generic file system, they use the 512 byte. Sometimes database like the Oracle Informix DB2 MySQL, such a database, relational database use several K, 2K, 4K, sometimes the 64K kilobyte size the block. However, the big data system is mostly deal with a bunch of data, the huge size of the file. So they are using the 64 megabyte or 128 the megabyte size block, which means when you read the data, entire 64 megabyte of the block on your the HDFS will be loaded into the memory. Okay, so this is one of the characteristics. Because of that, when you set up the big data system in your company, or when you design architecture of the Hadoop system, your computer can be generic, the personal computer or workstation computer, but it is recommended to have the bigger size of memory. So it relies on the huge size of the memory. Okay, so this is the first characteristic. Also, one of the problems of the distributed file system is it relies on the network connection. So network connection is not such a reliable. Sometimes disconnected, sometimes slow, sometimes the malfunction on routing, so it cannot be reached. So because of that, if you manage it is required when you build a distributed file system, the failure tolerance, which means your system, in case of something happen, but your system should be available. So in Hadoop system, how can they achieve such a partial failure tolerance? So they are going to copy the data. So if you upload a file like this, it's not just one block, another block, exactly same one will be copied. Just one copy? No, minimum 3 copies of them. Even though one of them is not accessible, the other 2 is still alive. Also, it's not only for the failure. Sometimes if this system is slow, very slow, but the other 2 are okay, then you can change the processing. Okay, so this is the way how we can keep the high availability. So 3 copies. Depending on the settings, so it can be more. 3 copies of the data. Okay. Then, what else? What other characteristics we discussed? This Hadoop is HDFS. Hadoop system is basically based on Java. So they are using the Java programming the framework to build all of them. Also, it communicates through the HTTP. It uses the HTTP protocol, which means if you are using web browser, so by typing URL, sometimes you can directly access the data. Also, this Hadoop system has master plus slave, the architecture. So there's one master node and multiple slave node. This master node is called the naming node, and this slave node is called the data node. So you have the multiple data node. Then this naming node is a single point of failure, which means if this one is not working, your entire system will be down. So because of that, you may have the standby the naming node. In case one of them is not working, the other one will take over the job. And also there's a secondary naming node. The secondary naming node is to reduce the burden of the naming node, the master node. It actually take apart some part of the job. So this is the overall architecture of that. This master node keeps all the metadata of your Hadoop system. Okay? So this is the Hadoop distributed file system. It's called the core component. So in other words, when you install the Hadoop system, this HDFS will be created along the system. Question: how do I select which one is the master node, which one is the slave node? So you are going to decide which one will be master, which one is a slave. However, nowadays, when you download the Hadoop and if you specify the network, it automatically selects contact each server, then check the capacity of the system. Then select this one is the master node and the other will be the slave node. Also, mostly our system virtual machine is tested, which means we are using only one computer virtual machine, and we put the master data node and naming node, everything inside. This is called the pseudo cluster. Cluster system is when you have a number of computer nodes then the combined together to one is called the cluster system. So we pretend the cluster for educational purpose. However, in real, the implementation of the Hadoop big data system, mostly the big data system will not be in your office, right? Instead, it will be at the data center. So data center is geographically sometimes separated. Data center 1, data center 2. So they are connected with a very, very high speed, the network, like the fiber optic channel. Fiber optic channels are used to connect the two different data centers. Not just two, we have many. Then each data center has the number of rack. So rack is one rack has a number of the blade server. Blade server means we don't have to have the monitor, mouse, keyboard for each computer. Instead, what we need is just the motherboard and the connected CPU memory, even minimal local hard disk drive. Then we can share the storage as a storage area network cell like that. So this is the rack. So rack is kind of the refrigerator style, the box. Then you can plug in the blade server to number of blade server. Then you have number of such a rack. Then sometimes the Hadoop calculate the distance, topological distance between the computer in the same rack and between the rack and between the center. Okay? Then they are going to assign the block. One is here, another one is here, another one is here, like that, for safety purposes. So this is the Hadoop system, Hadoop distributed file system. Then this is one core part. Another core component is after you install the Hadoop, then load the data. You learned the last time how to. This is the common mistake or the confusing part for the beginner when you are using the Hadoop. HDFS is the file system where you keep the data, especially big file. However, this file, another characteristic of this one is it's running on top of generic file system, other file system. For example, I have the NTFS, the Windows file system. If you install the Hadoop system, this one will be one file from the NTFS point of view. But this one actually connected to the, logically connected to the another file on this, another file to this one. It is recommended when you build a cluster, it's all the servers are identical configuration. Recommended. Recommendation means in case it's different, the server it works, even though. But it is recommended. So each server has such a HDFS. Because of that, you learn the last time during the exercise, you can put a file. Put from the OS file system to the HDFS. Or you can get the file from the HDFS to here. So this is the HDFS. So after you install the Hadoop and set up the Hadoop system and using HDFS, upload the big data, like the healthcare data, then what will be the next job? The reason why we keep the file, big data on HDFS is not archiving purpose. It's not backup purpose. We try to process such a data. So how can we process? So for the process, we need the programming, the framework. So for the programming framework, we are going to see map reduce program. Okay? So this is another core component of the Hadoop system, Apache Hadoop. So Apache Hadoop basically is to HDFS and the MapReduce. There is another 1, 2, 3. Another core component is called the YARN. Yet another resource negotiator. So YARN. So first time when the Hadoop system was proposed, okay, and released, they have only two core components: file system and the programming framework. Then the problem is it worked very well at the time. So, but comparing to the big data system or the distributed system, it works really fast. The problem was when they have the Hadoop system, this one is slow. This one is very, very busy. Can I use this one? Also, this one capacity is the 10%, the other 90%. So can we store the data on lower capacity? That makes sense. But first version of Hadoop, they don't have such a resource manager. So people realize that we need something research. When we run the job, why don't we consider the node or computer that is not busy? That makes sense. So there should be something the part who negotiate the resource, then finally manage the resource. That is called the YARN. So YARN is in charge of the resource management of entire system. In other words, later when you run the program, I have the MapReduce, the program running on the HDFS. You can select either YARN or without YARN. So our practice will be based on without using YARN because we have a pseudo cluster. It doesn't make sense to consider the resource manager. But in real life system, when you run your application, the MapReduce program, you can select the YARN option. Then the YARN will check the resource, then allocate the node, which is not very easy, okay, for better performance. So these three are called the Hadoop core component. So when we are saying that when you install the Hadoop system, that means the three components are installed. Then, are they all the component of the Apache Hadoop? No. So on top of that, so we have the HDFS, we have the MapReduce framework, and also we have the YARN resource manager. These are the core components of the Hadoop system when you install. Are they all? Yes, you can do that, everything, but later you will realize MapReduce programming is not that simple. Even though one of the characteristics of the MapReduce is it actually remove any housekeeping job, so you can focus on the big data processing, but not real story is not there. Sometimes it's hard. So to address that one, based on this, there are software. As we have seen the last time, Hadoop HDFS, they provide the API to access the file and the program. So based on that, some of the software focus on the programming, make them easy, like the peak or high. Some of them focus on ETL, like the school. Get the data from relational database into Hadoop, like this. So ETL means the extraction data, transform data, and load the data to a data transfer. So it's good. And from. Also, this one is the file storage, but it's not very convenient. Another characteristic of this one is write once, read many times. Which means once you write, you cannot modify the data. And also only append. So is there any other way to address such a thing like the we'd like to use this system as the database system, Hbase. And there are more and more the software are coming. So this one is called the Hadoop Ecosystem. The reason why it's called the ecosystem is, as you can see, the name of the product is pig, hive, bee, and school, flung, H. So their name are essentially, their names are after the animals a lot. So even there is a zookeeper. So because of that, we call such a group of software as the ecosystem, Hadoop ecosystem. That is because of the dog cutting. Dog cutting, when he proposed the big data solution first time as a GFS, then he named after his son's toy, the elephant toy, Hadoop. So that after that, it's called a lot of animals name. So today we are going to see some of the Hadoop ecosystem software plus how MapReduce is working. Nowadays, less and less MapReduce is being used. Instead, Spark replaced that position. So that is the reason in this class to focus on the NoSQL data. So we are not going to cover the Spark. Instead, the Spark is discussed in the big data class. So Spark, actually, when I started the big data class 6 years ago, at the time the MapReduce only. Then the Spark has been released. Then there is version 2, nowadays version 3. Recently version 3 is released. Then almost the 70-80% are based on the Spark. One of the characteristics, the main part of the Spark is MapReduce only for the Hadoop distributed file system, which means data source should be this one. Cloud-based system allows some of the cloud-based storage, but Spark doesn't matter. It can access the data from the HDFS, it can be local file system, it can be any types of source. And also performance nowadays is even better than the MapReduce. However, still the MapReduce are being used in the big data system to focus on the main concept of the divide and conquer. So MapReduce is still being used, but it is to more and more the Spark application. So keep in mind. So if you are very interested in the big data programming, so you should know about the Spark. Okay. Let me erase this then. So we are going to see the Hadoop, the ecosystem first, then followed by the MapReduce programming. So this is the overview of the Hadoop ecosystem. So Hadoop ecosystem is a group of software running on top of the MapReduce as well as the HDFS. Nowadays, we have another main component that is the YARN, so the resource manager. So today we are going to see very briefly each of the Hadoop ecosystem, the software. Okay. So Hadoop ecosystem. So if you want to know more about the Hadoop ecosystem, first go to the Apache Foundation project, Hadoop project. Then you can find most of them. So some of them are retired, but nowadays still the new Hadoop ecosystem project are coming in. So you can find more the software. But today I'd like to introduce the most popular and the generic, the Hadoop ecosystem software. So it is kind of the Apache project is kind of the incubator for the Hadoop ecosystem. You can find more and more. First one is Hbase. So this is one of the main solution of NoSQL database this semester. So Hbase, as name implies, is a Hadoop database. Okay. So why we need a Hadoop database, Hbase? Because the HDFS can be used as a storage of the big data solution. So which means from the MapReduce programming, you can directly access the data HDFS and get the data and return it. The problem of that, it doesn't support update. You cannot delete the data. Even. Second part is, this is a serious part, it does not support the indexing. So in database, why do we need the database? It's not the NoSQL database, it's a generic database. Why do we need the database? The reason why we use the database management system are very, so really a lot of reason. Like for example, we'd like to keep the data security, and access the data, and search the data, and so on. Among them, the most important part is to access data very fast. Okay, efficient query is the main reason. If we have a small amount of data, we don't have to use the database system. The backup security is the next reason. The first reason is to access the data very fast, efficient query. Then how can we achieve such an efficient query in database system? Actually, using database is a burden, it's the overhead, because you need to have the bunch of the component and module run the program, but eventually the database system is faster than file system. How? The first reason is it can use a lot memory, reserved memory. So, for example, when you install Oracle actually recommend at least half, the 50% of your physical memory as the shared memory area, or the system global area, SGA. This is a dedicated, reserved area for Oracle processing. Then, if you have such a memory area, you can use such an area as a cache. It's called the buffer management. So, the bigger size the memory allocated, the faster your data is secured. That is one of the way to speed up your query. Another way is query optimizer. So you probably learned what is a query optimizer and how to do the query processing in your database class. The simply query optimizer is the way to select the it's a query optimizer, and query optimizer is the algorithm to select the fastest way to access the data. Because in database system, there are a bunch of different ways to access the data. Sometimes you can use this way, or join, bunch of different. Among them, we are going to find the fastest way. So that is a query optimizer. So second way to speed up your database query is using the query optimizer. The third one is by using index data structure. So our, for example, relational database model is stored at the table style data structure, like the row and column, and so on. Then, if you have more and more data, like for example, so this is the table of your customer. So your customer name, ID, and the address, so on. So when you have the 10 customer, it is not big deal to find the customer. However, what if you have the 10 million of customer? Even though this is ordered by the ID, you can use the binary search. Binary search needs what? Log n over 2. In case this one is block based, so you have a number of block, still the number of block based on 2 log. That is this one. The more data you have, the longer time it takes. So binary search cannot solve such a problem. How can we address it? We are going to have the different additional data structure that is fast. That point the data. So this is called the index data structure. This is a table data structure. This is indexing. So indexing is the smart way to speed up your query. What kind of index did you learn? Relational database use B3, actually nowadays B plus 3 index. B does not mean the binary. Binary is only 2 child node. You cannot use the binary, the 2 children node in the tree structure. It's really B3. So we are not going to use B means it's a balanced tree. So we can use the balanced tree to arrange the data, then we can speed up to access the data. So this is the index. So index is a really smart way to speed up our query. Okay. Then what about the Hbase, the Hadoop distributed file system? Hadoop distributed HDFS use memory, so it's okay. But still, it's only allowed the sequential search. Even it doesn't support binary search. So we can get the benefit of this one. So, and this is right once. We cannot add the data structure. Because of that, HDFS, the Hadoop distributed file system is good for the brute force, the processing, like the big data processing, batch job. But sometimes we need indexing. But HDFS does not support indexing. Then the people realize, why not? We have another software, another component that is called the Hbase. It's a database component. For what? To address the problem of the HDFS. That is called the Hbase. Hbase is kind of the first NoSQL database based on the big data solution. Even there, because it is based on the Hadoop system, there the volume of data is massive, like the bigger than petabyte size level. The relational database is good, but it's limited, up to several petabyte size. So because of that, most of the internet company, like the Facebook and Apple and Google, they drop, actually not drop, of the Oracle database or relational database for their main storage. Instead, they build their own database, which is called the NoSQL database. Hbase is one of them and the first one. Okay, so Hbase try to support the petabyte size level, huge size of volume, but it addresses the problem of the HDFS. And also another issue is of using the relational database is Relational database rely on relational model. So relational model means relation is a set, as we discussed before, and related important data. All the data, all tuples should be the same. Because of that, sometimes we use null and we focus on the no duplicate data, normalization, a lot of things will happen. That is a relational model. It's good for what? Online transaction processing and the data. We can believe the data. It's a really high consistent as we discussed the last time. However, problem, not flexible. So what if? So our data is not always name, ID, address. Sometimes name, ID, hobby. Name, ID, location, and hobby. It's depending on the data, it may be different, the format, right? Can we address that using relational database? No, you need to change the model and leave it again. So, because of that, it's not flexible and it's not convenient. We want to address such a thing in big data. Solution? Why? In a big data, one of the main issues of the big data is usually we cannot keep the consistency. If we need to keep the consistency on big data, really huge overhead. You need to do a lot of job. We give up, which means it's not consistent. But it's still okay. As I gave you the example of Facebook. Your friend post happy birthday, but sometimes you may not see such a comment. So it's a delayed, inconsistent, but it's still fine. Later, 10 minutes later or the day after, you are able to see such a data. So one of the characteristics of such a big data is you don't have to keep the very strong consistency level. So can we address that? So Hbase support column-based the database model. So column-based means depending on the data, we can add a column if needed. We can delete the column. We don't have to design the specific column, unlike the relational model. Relational model, first you need to start logical modeling and physical modeling and something modeling, then find customer is name, ID, address. That's it. Even though there's a new customer with different feature, you cannot. But Hbase is more flexible. You can add more column if needed. You can delete the column if not needed. So instead, the Hbase support column family, like the group of column, like the profile, and for example, in case of customer profile, under the profile it has the age, ID, and the address, and preference column family. Under the preference and clothes and sports and so on. So you can group it. So then under the group, you can create the column based on the data. So this is called the Hbase, starting of the Hbase. So we will see more details about the relational database versus the NoSQL databases. This slide shows the comparison between the Idbms versus the Hbase. Idbms, as you know, is a row-oriented. Once we design the column, then more and more, once you design the column name, ID, address, and data, new data. But Hbase, you can, if you want, you can add your column. You can delete the column based on the data. So this is called a column-oriented, column-based database. Actually, the relational database is not only for the row-oriented. We will discuss about it next week regarding to the relational database. It is a good idea to figure out what is really relational database, what are the limitations, and how we can address such a limitation of the relational database. Then we can find the way of using the NoSQL database. Also, relational database, one of the main features of the relational database is that you can use the SQL, structured query language. Well-known the format is select from where. Because of that, it is popular. What about the NoSQL database or the Hbase? They are not. Some of them are using the SQL. Okay, they are using SQL interface, but many of them just provide the API as a database. It's weird sometimes. Those who are familiar with the relational database model, they can find the query language. Instead, it's a programming interface like the API. Okay, and the relational database is support. It's one of the main characteristics of the relational database. Very well organized and designed indexing structure for any column. But Hbase supports a limited index, but it's better than HDFS. So row key only the index. Usually the volume level of the Hbase is petabytes, but relational database is I never seen actually the petabyte size the table up to terabyte. Okay. Even terabyte sometimes is only archiving purpose. You don't access the data. Instead, it's a 1991, 1992. It's a transaction history in one table, partition table. Then the only recent data. Think about it. When you access the bank, I'm using Bank of America. From time to time, I check my transaction history. Do I check the 10 years before transaction? No, I don't. Recent, last 10 days or the last month, the transaction. So because of that, the relational database is very limited, the data size. So looks like the Hbase is good, but it cannot solve all the problem yet. Okay, so you can use the HDFS if you have only appended data. It's a kind of sensitive data. So as I keep saying, the NoSQL database is the not replacement of the relational database. Instead, you have the relational database as well as the NoSQL database. They are not. Sometimes it's overlap, but mostly it has its own characteristic. So for example, if you have the random access in the big data processing, you can use the Hbase. Okay? And the volume of them is bigger than terabyte, you can use the Hbase. But still, Idbms is suggested. Okay? So we will see more details of such a case when we discuss on the Idbms next week. That is Hbase. So we will have a time to discuss more details of the Hbase in terms of data modeling and types of the Hbase and how to use the Hbase database in the middle of the semester. Then the next ecosystem is Flum and Scoop. If you see the name of Flum, if you go to the Vermont, or what is the main Vermont? What else? New Hampshire. If you go to such a northeast upstate part, so sometimes there is a place like a Flum. So Flum is the kind of the long time ago. There is this is a mountain and the trees are like. So we need to use the tree as a log, right? So for the craft to make a desk or some fire, so they cut the tree and make the log, and they transfer this log to the port. How can do that? they can use the river or stream. But not always there's enough the size of the stream on the mountain. They artificially create the stream. This is called the flow. If you go to the amusement park like the Disneyland has a flow ride. You can ride the log and slide down. So this is a flow. So flow is like moving the log tree. So we can regard such flow as a data. Data will be transferred from one node to another. Usually from sensor node to the big data node. Big data system like the Hadoop system. On the other hand, the scoop. If you see the name of the scoop, SQ is come from SQL. Scoop. But if you are hearing the name of a scoop, what can you imagine? What can you imagine from the scoop? If you go to the ice cream shop, you are going to order the ice cream, like the one scoop of strawberry, another scoop of the chocolate. Like the scoop is like this. So if you get the data from the SQL, which means Relational Database, Idbms, to the Hadoop, HDFS, at that time you can use the scoop software. It's the data transfer software from relational database. Like you can scoop the data. So this is the scoop. So what is the flow? So flow is you can see it's called log file. Log is the pretending the log tree. Okay. So we are going to transfer such a log file into HDFS using Flum software. So Flum is based on the agent, like the service program. So when you have this is a HDFS Hadoop system. So you have number of the server. Each server generates a log file. Network log, network log, network log, network log, network log. So each server has the service agent program. Service agent program and check whether there's a new log. If yes, get the data and transfer, and eventually store such a log data into HDFS. Okay, this is called the Flum, the Hadoop ecosystem. Okay, Flum is distributed, definitely is distributed along the network, and reliable and also available, which means if one of them is died and the other is still working, and if this one is died and they send the data and eventually transfer the data to the Hadoop distributed file system. Also scalable, which means if a new node is, this one is very busy, their agent program is the multiple, and it can support the scalable. So this is a very high level overview of the flow. So you can see that there's an agent program for each server, then they combine into one, and eventually there's an agent in the middle, and finally stored at the HDFS. Okay. So this is the flow. On the other hand, the scoop is from the flow. You can get the data from any file, any server and any file. So specifically log file. What if the data is in the relational database model? It's different from the file. So at that time you can use the scoop. Scoop is getting the data from the relational database. It's very complicated. Actually, this one is very simple. If you already took the database class, actually you can create the scoop software by yourself. How? How can you access the data to the relational database? You can use JDBC. JDBC is a Java database connectivity. It's a common open library to access the relational database. So From this side, you can, using the JDBC, you are able to access the data. Then load into the HDFS. You can do the programming. So this is called the school. Vice versa. You can read the data from the HDFS and store such a data into the relational database source. So it's just equal to Hadoop school. Okay. Let me check the question, the middle. Oh. What is the third way to speed up the DB? Oh, it's a little bit, okay. So indexing, using index. That's what so first one is the memory buffer management. Second is query optimizer, query processing. Third one, you can use the index. So such an index is not available in Hadoop system. To address that, we have Hbase. Hbase supports the indexing. Okay, that's the answer. Then move to next. So, school, as long as the JDBC is available for the relational database model, so you are able to connect the relational database model, DBMS, Idbms to the Hadoop system. Okay. For the data processing, I'm going to quickly introduce the Spark, and also it's very, very important. So, but in this class we are not going to cover the Spark. So, if you are interested in the big data processing, today I'd like to introduce the MapReduce, but also you should know about the Spark. So, Apache Spark is faster and it's generic. So, general purpose the query engine for large scale data processing on a cluster. Here, it doesn't say that it's a Hadoop system. One of the main characteristics of using the Spark is the Spark is based on not only the HDFS, it can be the local file system, it can be the even CSV file, it can be cloud-based, any source are supported. It's from the AMP lab in the UC Berkeley, which is a very popular computer engineering, computer science lab. Okay. Current version is the Spark 3, but I don't recommend to use the Spark 3 yet because it's open source. They usually not evaluated. So Spark 2, if you want to learn the Spark 2 is good. Then, what is by the way Spark? So you can use the Spark, the component with the host language. So which means, if you want to use the Spark based on the Python, so Python is the host program language. Then import the Spark library, and you are able to get the benefit of distributed processing. You can use also Scala, or you can use the Java, but the Python is the most popular one. Almost real-time streaming data processing, because log data is coming every time. So like the network log, people are accessing the web server and the log data, and then the process real time. That is done by the Spark. Then we have today I'd like to introduce the MapReduce, but later you will realize it's not so easy. I should know Java, and I should know the concept of object-oriented programming. Then eventually I need to come up. So it's not that simple. So people actually give up to use the MapReduce programming. That happened a lot before. Like for example, here I'd like to introduce the Pig. It's a program language interface in big data system. Pig Latin, sometimes it's called the Pig Latin because it's based on the Pig Latin script language. Pig actually was developed from the Yahoo. So Yahoo encountered the same problem as what the Google had. So they want to address the problem of the volume of data. Yahoo is also a search engine company at the time, the 2001, and then the Google released their own for GFS. Then they said that this is what I wanted, so they write to the other employee. They're using the Hadoop system. The problem is, Hadoop is based on the MapReduce. MapReduce is based on the Java. The developer in Yahoo should know about the Java, but they don't want to learn the new program. It takes a time. And also, if they want to hire the new employee, they need to fire the existing employee. Instead, they decide to develop the new programming interface. So this is the Hadoop. Programming interface is a MapReduce. Then you can process. But to directly use the MapReduce, not easy. So on top of that, they learn the programming interface. That is called the P Latin. So it's a script language. So using script language, they can access this Hadoop data and join the data and return the data. While you are using the P Latin, the script language and command, it's automatically converted to the MapReduce program behind. Then this one access the data and return it. So this is the P Latin, the programming interface. Performance definitely lower than the MapReduce. It's the original the map because it's the programming one level more programming interface. But their productivity is much higher. They can save a lot of time. Instead of learn the new program language, they can actually develop the very easy programming interface. So that is a P. Hive. So Hive is the same thing. So Hive and the P is for the kind of script language. On the other hand, Hive is the really SQL style. It actually supports the SQL version 2, SQL 9092. So most of if you already learned about the SQL, that is based on the SQL 2 standard. Then the later SQL 3. SQL 3 adds some new feature like the object-oriented concept and so on, but most of the feature used in the SQL is the SQL 2 standard. This Hive supports the SQL 2 standard, which means you can select some the data from Hadoop file and even condition like this. Then this query is converted to the MapReduce program automatically. Then get the data and return as a format of the table. Then we don't have to worry about the MapReduce. Then instead we can directly use the SQL. Even this one will be combined with the scoop. Using the scoop, you can get the data from Hadoop and store the data into the relational database. You can access the data using SQL style. So you don't have to worry about it. Even though you do not know the MapReduce and Hadoop, still you are able to use the big data solution using SQL and the scoop. So, but don't forget, even though we are using the SQL style query, that doesn't mean the data is the relational database. No, it's a still Hadoop file. Okay, it's only interface. So like this one, you can see the select asterisk from the project where price is higher than the 10,000 like that. You can understand this one. What if you are asked to make the new MapReduce program this? You need to understand what is the mapper, what is the driver, what is the reducer, and the compile. It's complicated, but you can just use the SQL style query to access the Hadoop data. That is the benefit of using Hive. Pega is the same thing, as you can see. So the line by line, the interpreter, the script language. Okay. For example, project low data where is a source. That is HDFS, the URL, as item ID, and price is comma separated. Then put such a data into projects. And the big ticket is filtered where projects by the price is higher than 10,000 will be stored at the big ticket. Then you can do something. So this is the pig Latin, the programming interface. Impala is actually the Cloudera. So as I introduced the Cloudera is the big data company. They are not Apache Foundation company. Instead, they are the company to utilize the Hadoop system. Then sometimes they create the new software, develop the new software as a part of the Hadoop ecosystem. Impala is one of them. It's a high performance SQL engine. Okay, so but I never used such an Impala. So it's just from the, I don't see even the company. Uzi is another example of the Hadoop ecosystem. So for example, main purpose of the Uzi is managing the workflow. What is a workflow in a company? So I have the system that can address the problem of A. But depending on the result of A, so bigger than 50 and less than 50. So you can run the B1 solution or B2 solution. So this is called the workflow. So mostly such a workflow can be managed by operator. So operator see the result, then run this one. If you are using the Hadoop ecosystem, Hadoop family on the big data solution, Uzi is managing such a workflow. So that is a workflow management of the software. There's the last one is the Maout. I heard that the Maout is the name of the philosopher in India. I'm not sure. So, but the Maout is the Hadoop ecosystem for machine learning. So it has, but data should be HDFS. When you have data in HDFS Hadoop system, but I try to employ the machine learning, like the classification, clustering, regression, the recommendation system. At the time, you can use the machine learning library, the machine learning software. It's a Maout. So Maout is a machine learning library written in Java, running on the Hadoop. Okay. So they support many. These are the limited ones: collaborative filtering, recommendation system, and clustering, the unsupervised learning, classifications, the supervised learning, clustering, unsupervised learning, and but many other. Okay. So in addition, there are more. Really, some of them already retired. Not every day, but whenever I check every semester, when I check the Hadoop ecosystem, more new. Even it's very hard to catch up such a new software. So it depends on your requirement. So when you join the company, so when you try to build your big data system solution, you can check what are the available. The Hadoop ecosystem, and depending on the objective of your project, you can select this one, and this one. I'm going to skip this part. It's managing the system. Then, after the 10-minute break, so 7:25, so we are going to continue to learn about the MapReduce. 10-minute break from now. Continue the MapReduce part. I'm going to a little bit speed up. So we are not going to cover details of the MapReduce programming. Instead, regarding to the programming, including the Spark, will be mostly covered in the big data classes. But in this the class the rest of the time, I'd like to brief the idea and concept of MapReduce in the big data solution. So what is a MapReduce? As I explained several times, there are three main components of the Hadoop, the big data solution. One is the HDFS. We spent a lot of time the last week and this today, and where we store the big data. That is the most important part. Then eventually we should be able to access such a data and process it. That is the MapReduce part. Then for the better performance, we need the YAN, yet another resource negotiator, resource manager. So MapReduce, as name implied, there are two parts. So to understand the concept of MapReduce, so you'd better understand the divide and conquer. So in the algorithm class, you learned about the one of the approach to solve the certain problem is the divide and conquer. So which means if your enemy is too big, so divide the segment, the problem, then address one by one. So distributed the system, they usually use a parallel programming, which is based on such a divide and conquer. We are going to use the same approach to access the big data and using the Hadoop system. So what is the MapReduce? To understand the MapReduce, the first you'd better understand what is the key and value. So specifically key. So because of the relational database model, so if you already took the database design or advanced database design, so you heard a lot about the key. What is a key in the relational database class? Key is a set of group of attributes that can identify the tuple or record. That makes sense. So using a key, then we are able to find, search the data. Among the several keys in a table, we are going to select one of the key as the primary key. So that is a PK. So primary key is unique and unknown in relational model. Then our goal is to find such a PK. Then using PK, we can find the data very fast. That is the primary key. That is the key used in the relational model. Because of that, it's very hard to explain key in general. Actually, in data, the primary key is a very special case. Primary key. Sometimes you cannot find the primary key. Primary key is only for the relational model. Because as I said, the main reason why we are using the database system is to access the data very fast. So there are several approaches to speed up access the data. Primary key index is one of the features. Really, really fast, and because of primary key, we can keep the consistency also. However, such a primary key is a very, very, very strong constraint. How can you keep the primary key? You need to sort the data every time. You need to verify whether there exists the value or not. Also, non-null and unique, you need to check. It's the overhead. Big data solution cannot keep such the primary key. Instead, when you understand the data, such a big data basically recognize the data as a record. So record is the same as the one line. In terms of a file system, it's separated by the new line character. As we have seen before, it's a new line character. One line is the one record, is the one data. So that is true. That makes sense because the big data system comes from the log data. The Raw data is line by line event. So we can regard one line of data as a record data. This is the value first. Then what is the key? Key is just a key. What is the key of yourself? Name. Sometimes you can find your friend who had the common name, same name. It doesn't have to be unique. It doesn't have to be non-unique. It's just a key. Key is the identification of representative of your value. That is a key and value. What we are interested in, this key can be comparable. Instead of compare the value, we can compare the key. If we need it, we can sort the data using key. Value is just the data. So we can simplify the structure of the data, key and value. We don't have to consider PK and the foreign key and attribute. This is used in the relational model. Too much complicated and overhead. That's the restriction. Instead, we regard the data as a line. One line has the key and value. This is the unit of processing in big data. Then map reduce. Map reduce is, as name implies, map and reduce. One of the characteristics of the HDFS is the block and block. As I introduced last time, the traditional parallel system, distributed system, focus on one, computation. So our goal, objective of traditional distributed system is to bring a data to the CPU. You need to read the data, then process computation. So it's a more computational oriented system. However, nowadays it's a data-driven. Data are more important. Data are the bigger and bigger. So it's really time-consuming to bring all the data to the computational node. Instead, it's a vice versa. Bring the computation into the data locality. It's called the data locality. So block is big enough, 128 megabyte block. So then assign the algorithm. That is called a map. We are going to first, it's kind of pre-processing. Pre-process such data on a local block. The traditional system, we bring a data into computational node, computation, CPU. But here, we are going to assign such algorithm processing into the local block. Local block. Map for each node, map. Then, output of this map will transfer to the reduce. Because they are divided, we conquer. That output of this one should be combined into the reducer. Sometimes one, sometimes many. Mapper is many. Reducer sometimes one, sometimes many, depending on your setting. So, this is an overview, very high-level overview of map reduce. Then, what are the processing of mapper? So mapper usually emit the data. Emission of the data means we are going to chop and select the data what we want. For example, this is a kind of the Hello World style. So I'm going to use this slide. So in this slide, I'd like to count word. So, for example, how many A? 1. So A is 1. How many abstraction? abstraction count abstraction 1, and how many the can count, let's say 3, like this. This is a word count. This is our big data problem. If we apply the map reduce is first, this is one block. This is one block. One block has the huge the text information. How many blocks? Really many blocks. So for each block, we are going to apply map. Map algorithm is you are going to design. What? How can you count? There are different ways. This is what I'm going to do. First, such a big data is line by line. So first, MA. First chop by line. Okay? So this is one value. Value, this is a value, this is a value, this is a value, this is a value. But each value should have the key representative identification. So we are going to assign the key. This time we can assign the key as a 1, 2, 3 line number. Or we can use the offset. Offset means it's a 0. Because if you assign the 1, 2, 3, you need to increment the value. Right? It's a computation. It's the overhead. So that's the waste of your CPU. So can we save such a CPU instead? This is a location 0. This is a 0, 1, 2, 3, 4, 5, 6, 7, and 53, and this one is a 54. So we are going to use such a offset location of the beginning of the each line. You don't have to calculate. No computation. Just byte by byte the data. So this is 100, this is 126, like this. So key is offset 0, this is the value. Key value, key value. So we have a number of key value. The next, we are going to set tokenize, like this. Space, 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 right? So tokenize on this. At this time, what is the key? What is the value? This is the key. 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 So, for example, automatic is a key. And what is the value? How many times? It's one time. 1. And parallelization? 1. And the end? 1. If there is any end over here, and 1, and 1, like this. You can tokenize by word. First, line by line segment. Word by word segment. Then, the next job is, we in this block, we have the list of such a thing. Then, another block has the list of this. Another block has a list of this. We need to combine all of this, right? For the final. Then this one is a reducer. Reducer, sum of this. But by what? By key. By the key sum of this value. Just add up. This is a map reduce. So what you're gonna do is, you need to design how to eventually solve the problem from the map and finally reduce. So that is the key value design. So we will see more details of the such a example. So mapper is typically operate the single HDFS block. So you are going to code for the algorithm to process on each block. Mostly emission, mostly segment, key and value. Then reducer will combine all of the output from the mapper. Output from the mapper. However, in the middle, there is called shuffle and sort. Shuffle and sort means if we send all each key and value, it's a network overhead. To reduce such a network overhead, if I can combine together in the mapper, one block, we can save the, for example, we have and 1, and 1, and 1. Instead of sending all three key value, key value, key value, why not sending and 1, 1, 1 key value like this? Then we can save the network traffic overhead. At this time, somebody may argue, can I add like this? 3. Yes, it's doable. The problem is you need to do the computation. 1 plus 1 plus 1. Instead, just sending array. Computation is most expensive operation in computing. This one is okay if you have just one case or the several cases. However, big data, like the billions of cases, it takes a longer time. So we do not calculate, instead of combine. This one is called the shuffle and sort. So 3 steps, but we don't have to do anything for shuffle and sort. It's automatically done by the MapReduce framework. Just focus on the MapReduce. This is the flow chart how the mapper and the reducer is working. So from the input file, the input file has a number of the block. So each block separated by the record, line by line. Okay, here is a record reader, it's a line by line, and mapper algorithm is applied. Then shuffle. The mapper, what mapper is doing is make the key and value. That is the output of the mapper. Then shuffle and sort. Then this shuffle and sort will be combined into the reducer. So reducer will apply the algorithm, final the algorithm. So what you're gonna do is only focus on mapper and reducer. The other part will be processed by the MapReducer component automatically. So that is one of the characteristics of the MapReduce. So let's see the word count example. So simple example to understand the MapReduce. So in this example, input data is a text data like this. Output is like the word for each word count like this. For example, the cat sat on the map, the aardvark sat on the sofa. So how many aardvark? 1. How many cat? 1. How many on? 2. How many dog? 4. This is what we want. So to do that, so from the record reader, this will be automatically done. So for each line. Then we need to design the key and value eventually to count the word. Then the first processing is a record by record. So this is a value. What will be the key? Less computation. So we can use 1, 2, 3, the incremental number. But when you are using 1, 2, 3, the sequence number, it will be what? Computation. So we are going to use something non-computational information like the offset, location of the each one. So 0, 23. This is called the offset. You can use a different one. Then this one is the first key and value. But using this, we cannot count the word. We need to the separate by the word, split by the word. So the cat sat on. So each word, how many times? 1 time. So the 1, cat 1, sat 1, on 1, the 1, map 1, like that. Then another mapper is processing the 1, so keep doing. Then this one should be sent to the reducer. However, before we send the reducer, the on how many times? 2 times. Set how many times? 2 times. The how many times? 4 times. Instead of sending the 1, the 1, the 1, the 1, why not sending the 1, 1, 1, 1? If we send the 4, we need to calculate. So to avoid the calculation computation, just array 1, 1, 1, 1. So the 1, 1, 1, 1, is the output of mapper. Similarly, here, the dog 1, elephant 1, mouse 1, dog 1, 1. Then this output sent to the reducer. So it's a separate node. Reducer will be running separate node. Where? We don't know. Who is in charge of that? It's the resource manager. Resource manager will select the available one for the reducer. So this one will be calculated. Adblock 1, cat 1, the mat 1, and so on. Then reducer will add up sum, because it's word count. To count, we need to add up by key. So adblock 1, cat 1, the mat 1. In this case, we are running 3 reducers. So it will be split into the 3 parts. The final output should be combined, if you want. If you specify, you can specify the number of reducer in your program. If you don't want to separate, it can be reduced in one node. So all of this, the data will be combined into the one node. Okay. So more details of the code in the mapper. So what mapper is doing is the key and value. Key and value. Make the key and value for final to solve the problem. Key and value. So for example, so this is one line and the key and value and the word and one. So somebody said the big data programming and especially the map reduce programming is designing key and value. It's not programming skill. It's designing how to get the data eventually. Use the processing emit by emitting the key and value. There are several the use cases in the key and value, but I'm going to skip this part. Sometimes we can apply the filter mapper. So for prime number only, like that, whether it's a prime and the second. It's not prime, the no, and the prime, yes, the return. Okay. There are several different use cases. Identity, the mapper is the same thing, just send the SADs. Reducer is combining. So in case of count means you need to sum up. In case of average, you need to sum and divide by number of keys, like that. So that is the reducer. This is the sum reducer. Sum reducer is the most popular one. And average reducer, as you can see, sum divided by counter. Identity reducer is SADs. Key and value will be here. Okay, so you are going to practice with the word count example with the source code during the exercise lab. Please take a look at the code in the exercise lab and then see the example of that. In this class, so we are not going to focus on the map reduce programming details, the how to code, how to use. Instead, the programming part will be discussed more details in the big data course with the Spark, the program. Okay. So then we have discussed about the HDF first. We have discussed about the map use programming, and then there is another one, the YARN, the resource manager. So we are going to see the all together. This is called the Hadoop Cluster. So what we're gonna do eventually in industry, we are going to implement such a Hadoop cluster system. So when we are saying the Hadoop cluster system, we should have the cluster computer, the number of nodes. Okay, then one of them will be used for the master node, it's a naming node, and the others will be the slave node, it's a data node, processing node. Okay, then each node will have the number of processes, which is called the daemon process or service process. For example, data node has a data node, the service program. Naming node has the name node, the daemon process, service processes, like that. So, for example, in this case, it's 1, 2, 3, 4, 5 node. 4 of them are used for the data node. One of them is the naming node. When you start your Hadoop cluster, then the naming node daemon will be started here, and the slave node, data node, has a data node, the process, daemon process will be running. There are 2 versions. That is the yarn. So MapReduce version 2 is based on the yarn, resource manager. Previous version does not support the yarn. There is the resource manager, but it's a very simple resource manager. It's not complicated. So we are saying just the old, version 1, the MapReduce. So first time it was good, comparing to other parallel programming, but as the volume of data is growing a lot, it's bigger and bigger, so we need a more sophisticated resource manager. So that is the birth of the yarn. Okay. This is, let's see the MapReduce version 2 based on the yarn. So we have the resource manager will be in charge of the processing the MapReduce programming. Then, where's version 1? Yes, here. So, for example, here the resource manager is running on the separate node, or sometimes it can be the same node as the name node. It's up to you. But it is recommended to run the resource manager in the separate node. Then, when you submit the job, it's not submitting to the naming node this time. So you can submit the MapReduce job to the resource manager. Then resource manager know which server has how much capacity it has. Then first assign the MapReduce job for the application master. Application master is a service program which will be in charge of that submitted job. Then this application master and negotiate with each the data node. Then find the available resource from here. Available resource here. Available resource here. Where there exists the data node, the data block. If there is no data block here, you should not. Okay? So this application master definitely communicate with the naming node, because naming node know where data is saved through. So using this one, so negotiate with the data node from the application master, and finally decide. So you are going to process this, you are going to process this. Then that is the map. Once mapper job is done, they send upload mapper to the reducer. If at that time the application master also decide to the which node will be reduced server. Then that is the different from the old version of MapReduce. Old version, they do not use such the application master. Instead, the naming node directly contact each data node. Okay. This is the old style. This is an example of your exercise last week. So you can use the Hadoop command or the HDFS command then to access the data, or through the programming. So you can submit the job through the client. But when you are using resource manager create application masters, the service program, and this one contact each node like this. Each node, whether they are they have enough the resource. If yes, then run the map task, the map person, and also find the reducer. Okay, so in your exercise, you will see more details of the compiling and running the map reducer, and please practice with. Okay, that's the end of today's the lecture for the HDFS as the Hadoop ecosystem as well as the map reduce. For the exercise, the BAMC, the GA already uploaded the recorded video to our class playlist. So please go to the playlist, then watch the video, then with the help of description, follow the instruction for exercise lab. So this time is for the map reduce programming. So please see the source code of the mapper and the reducer, and at least you should be able to compile and run the work on the example. Okay. Then submit the screenshot or final output of your exercise lab to the Canvas. Okay, so that's the end of today's lecture. Any questions? You can unmute by yourself. Allow. So if you have any question, you can unmute. So
Professor.
Yes.
This is Peter.
Yes.
Can you repeat where we can find the video link?
Oh, video link. Oh, okay. So I think that I sent out at the beginning of class. Let me after the class, I will send the message together. Okay.
Thank you so much.
Yes. Always it's the same link. You can keep you can bookmark the link. Then throughout the semester, you can use the same link for any uploaded video. Okay. Yes. Next.
Professor, I do have a question regarding ASWE NE conference.
Oh yes.
Is the registration free, or is there a deadline for that we could do?
So this time the school does not support the registration fee. So instead, I think the student registration fee has some of them. I'm going to find, then let you guys know. Did you submit the paper?
Yes, we did submit the paper.
Mm-hmm. So do you have any professor? This is from the last semester? My course?
Yes, it
okay.
was from the last semester and it was under you.
Ah, okay, I see. So I'm going to find.
Okay.
Yeah.
Thank you, Professor.
Mm-hmm. Any other questions? Okay, thanks so much for today's lecture. Then good evening and stay safe. So we will see you next week. So meanwhile, why don't you complete your exercise lab and homework. Also, if you get the comment from me regarding to the phase 1 submission, please address it. And otherwise, you can continue to work for the phase 2 of the task 1. Then we will have the presentation based on your research on your selected database. Thank you and good night.